Hi everyone, this is Subnet Zero. So today we will be focusing on the flaws of the pre 1993 IP class system, why it became obsolete, what was the solution, and how the network engineers created a new infrastructure that essentially made the old infrastructure obsolete. Okay, so without much time, let's get into it. So this is the pre-1993 class system. In the previous video I taught you, which is class A, that is not 0 to be fair. It's like 1.126, yeah. It's 1.0.0.0 to 126.255.255.255. I'm not using the accurate mathematical term. I'm only using the one which was which was utilized in practice, okay? Then there is class B, that is 128.0.0.0 to 191.255.255.255, and class C is 192.0.0.0 to 223.255.255.255. And then there is a class D and class C. I'm grouping it together, and I'm just keeping it over here as of now. Okay, you can ignore that. Now, if you remember, class C had 254, and class D had around 65,000 approximately. Okay, if you remember, and this one had 16 million approximately. Okay, now there were two reasons why this model failed. Because number one, more and more people started being aware of the internet, and more and more people started connecting the devices to the internet. Okay, when there's an influx, when there's a giant influx, a giant flooding influx of more devices being connected to the internet, the network engineers can run out of IP addresses. Okay, and the second reason was that the grouping was not done fairly. For example, if in class C there are 254 usable IP addresses, but let's say if there is a company which who and they have like 300 or 400 employees, for example, so class C won't work. Instead, they will have to opt for class B, which is 65,000. That is way too many IP addresses for way too fewer devices, and that would be way too wasteful, and the internet will run out of IP addresses. So essentially, the network engineers came up with two solutions. One is CIDR, and one is private IP address blocks. Actually, it's not block; it's blocks. Yeah. Let's get into it one by one, and let's focus on first private IP address blocks. What does it mean? Yeah, so let me just clear the screen. Just bear with me a moment. Yeah. So what the network engineers did is something very clever. Before making this pre 1993 IP this IP class system, they decided that we will create an infrastructure of private IP address. Again, mind you, the pre 1993 all were public by default. But to create a new infrastructure for the private IP address blocks, what they decided is that take this take these existing classes, carve out a chunk of it, and convert them into private IP address blocks. Let me show you an example. Okay. So let's take this example number one. For in class A, the network engineers, they carved out this 10.0.0.0 to 10.255.255.255 and turned this chunk into private IP address, the 10 block. This is the first block. That is what we call as the 10 block. Okay, again, just to clear up a potential confusion, is that this one that you see, this model, it is the pre 1993 IP class system, which was all default a public IP address. While this one that you'll see, the ones you see below, it is private IP address blocks. Okay, please do not get confused. So, first one is the 10 block. Let's look at the second one, what it is. They carved out from class B, they carved out and they created a new block, which is 172.16. Yeah. So what the network engineers did is from class A, they carved out a chunk 10.0.0.0 to 10.255.255.255 and made this a 10 block. Okay. From class B, they carved out 172.16.0.0 to 172.31.255.255. Let me just fix this just a lot. Yeah. And in class C, they carved out 192.168.0.0 to 192.168.255.255. Okay. So first one is the 10 block, second one is the 172 block, third one is the 192 block. Okay. After this was carved out, this older system was made obsolete. Okay. So this is like the first solution. Okay. Since we are here, let me also cover one topic to so that the framework of for private and public IP address gets tattooed inside your brain, and you never have any confusion. Okay. Let me just clear up this board. Allow me a moment. Yeah. So, just while we are at it, I just want to tattoo one thing inside your brain so that you never run into any issues or any confusion ever again. So now that this private IP addresses, these blocks were formed, okay? Consider it like an island, like three private islands, okay? I'm making it in green because island has lots of trees, so I'm making it green, okay? So this is island 1, which is the 10 block, island 2, which is the 172 block, island 3 is the 192 block, and then there is class D and class E, the multicast experimental, which we ported over from the older model. So this class D and class E is still in existence. Okay. Now that we have our island set up, imagine the rest of this black screen over here is ocean. It's like a blue ocean. And let's imagine, the public IP addresses, which would be 11.5.23.78, or, some other IP address like, I don't know, 67.67.67.67. Guess we are doing the whole 67 thing. Then let's take up, I don't know, 56.32.45.21. Or, some other random number like 1.1.1.1. Or some other one, let's imagine, I don't know, like 89.45.23.89. Okay? Now, looking at the format of the IP address, it should be, intuitive that 11.5.23.78 is not a part of any of these, let me use brown once again, any of this infrastructure. So that means it is public. Anything outside this range is public. Imagine it being in the ocean, the white blue ocean. Anyone can access it, okay? Like 67.67.67.67 or 89.4.45.23.89. By now, it should be intuitive that these numbers fall outside the range. So by default, like in a blue ocean in the water, they are public IP address. This is another trick question, which some of you who are like, studying for exam might potentially be asked. So example, it is 192.169.0.2. It is a public IP address because it is outside the range of 192.168.0.0 and 192.168.255.255. So this is the setup, okay? These are private islands, 10 block, so 172 block, 192 block, and anything outside it, and this reserved range, of course, this class D and class E. Anything outside of it is all public IP address. So I hope this clears up any confusion. If next time you ever, see any IP address, you should kind of get an idea whether it's a public or private. So now that we have understood how private IP address blocks work, we can go to CIDR and how it works, okay? I know I have made it, left side right, but you'll get the gist, yeah? Now let's move over to CIDR, which is Classless Inter-Domain Routing System. What do we mean by this? So imagine if you're selling an ice cream in some kind of like exhibition, okay? So you'll need a stall for that. So you will not make concrete walls, right? You will use those makeshift, I don't know, either tin or wooden or plastic walls that you will use, yeah? You can create a stall with those makeshift walls. and maybe ceiling, anywhere. You can decide the size of it, you can decide the location of it, so it gives you immense amount of flexibility. Similarly, imagine classless inter-domain routing system, something similar to that. Okay, let me give you an example first, and then you'll get the gist. Okay, so some of you will come across IP addresses with slash and a number, slash notation, slash and a number, slash and a number. What does this mean? This is what we call CIDR, and it exactly acts like a makeshift shifting wall, okay? Which gives you plenty of flexibility, how you want to divide your network, what sizes, what range you want. It's like essentially it gives you plenty of space for customization. Let me explain how this works, okay? Before we proceed, let's get into the binary of each number in 192.168.0.1. Okay. So now that we have this, let me just expand this really big so that it'll be easy for you to understand. Yeah. So the binary of 192 is this, 168 is this, 0 is this, and 1 is this. Okay. So this is the first octet. Okay, so this one is what we call the first octet. Okay, this one is the second octet, this one is the third octet, and this one is the fourth octet. Okay, so this is how an IP address is converted into binary. Now I'll make some visual adjustments so that you'll understand how /8, /16, /64, how any of the slash notation works. Okay. Yeah, now that I've made the necessary adjustments, explaining this to you would be a lot easier since you'll have the proper visualization. Okay, let me just expand this. Yeah, so first, after converting the number one, let's take the example of 192.168.0.1, this one, the top one. Okay, let's take that example. And the number 192 that has been converted to the binary, which is this one, 11000000. And this is what we call as the first octet. Okay, the number 168, the binary conversion is this, and this is what we call as the second octet. Okay, 0 is this, what we call as a third octet, and 1 is what is the binary conversion is this, what we call as the fourth octet. Okay, now when we convert this into slash notation, how would it look like? Okay, over here, if you can zoom in, I recommend all of you to see this on a bigger screen because I could not format it any better than this. Okay, so if you're not able, if you're seeing on your mobile and if you're not able to like see what it is, please watch this on a laptop on a bigger screen. Okay, so this one that you see over here, that is /0. This one is /1. This one is /2. Then if we keep going, it is /7. Then /8. Then /15. It keeps going. Then /16. It keeps going till we hit /31. Okay. Now, what significance does it have? What does it mean? Let me teach you in the easiest way possible. Okay, let me clear this board. Yeah. Now, let's go in reverse. If we say /24 over here, for example, that means any notation, any slash notation, which is between /24 to /31, which means only the fourth octet is the host part. We will get a large variation of the host part from this, while the first, second, and third remain fixed. Yeah, they are the network part. Only the last part changes, the host part. Okay. Similarly, if it's between /16 to /23, then the third octet and the fourth octet will get updated. This will be host, and the first two will be network and network. Okay. If it's between /8 to /15, that means second, third, and fourth octet all are the host part, while the first octet is the network part. Okay. And if it's between /0 to /7, everything is host. Everything is host part. Yeah. First, before we proceed, I really need you to see this and internalize this. If you have understood the gist of it, I'll be moving to the next video, and the next video will be going through the entire CIDR calculation so that it gets absolutely drilled inside your head. I'm not covering this in this single video, is that the reason is I want to prevent learners burnout. Okay. So I hope you have understood this. I hope the visualization was helpful. And for further CIDR calculations, please click the next video. Thank you for watching the video, and I'll see you in the next one. Bye.